Yes, I'm Markus Nilsson. I'm a laboratory researcher at Lund University Bioimaging Center. But we shall not talk about me today. We shall talk about something much more interesting. That is, who are you? And how have you become the ones that you are today? And we can start that by thinking, were you the same 10 years ago as you are today? And for someone in their early 20s, as I guess some of you are, it's quite easy to say that, 10 years ago I was someone completely different. And during that time you have changed both in your physical appearance, your brain structure, but you have also gained a lot of experiences. But for someone 30 years of age, as myself, I used to think that my brain was fully mature by the age of 20, and that all that has happened since then was the accumulation of experiences. And that is what has changed my personality over these years. But can we test this hypothesis somehow? It turns out that we can, and one way is to put hundreds of people into MRI scanners and use a technique called diffusion tensor tractography. And that technique allows us to study the nerve fibers of the brain that connects the various regions of the brain. They're sort of the wires that hooks up the brain and connects the network in the brain to each other. And a group in Canada did this on a group of 200 individuals aged between 5 and 30 years of age. And they studied the maturation of the white matter. And to the left we see a structure called the corpus callosum. It's the structure that connects the two hemispheres to each other. And we see that the maturation increases rapidly from the age of 5 and onwards, but there reaches a plateau about the age of 10. Another structure, the cingulum shown on the right, continues to change all the way until you're 30. So apparently the age at which the white matter structures of the brain matures is different among different structures. And if you compare this in 17 different structures, as this Canadian group did, you see that they proved me dead wrong. By the age of 20, less than half of the structures in your brain has reached its maturity. And changes to your brain, of course, also influences your behavior. So, for example, the corticospinal tract is a tract that connects the motor cortex down to the rest of your body and allows you to have a good control of your body. And that structure isn't well matured until you're about 23 years of age. But what's most interesting, in my opinion, is one next second from the top, the cingulum. It's a structure connecting the limbic system to various parts of the brain, and the limbic system is involved in things such as emotion, self-control, learning, motivation, which I would say are quite fundamental for who we are as persons. And we see that structure hasn't reached its final maturity until the age of 27, 28, around that. So how can we then know all of this? The technique that we use is magnetic resonance imaging, and what comes to mind when you say MRI is usually these sort of morphological images where you see the general structure of the brain, my brain actually in this case. And those sort of common images, they reflect the chemical composition of the brain tissue. And on the right here we see that what's bright in the image is the white matter that connects the different functional areas of the brain. But we also see that there isn't much contrast in this white matter, so it's difficult to assess the maturity of the white matter. But for that we need to use something called diffusion MRI. But what is diffusion? Imagine that you would have just a normal glass of water and that you would be able to follow 3 molecules as they moved about in this glass of water. You would see that their motion was completely random, driven by the thermal energy of the water, and their trajectories would spread out in space over time. And if we would follow this motion over 1, 10, and 100 milliseconds, we would see that they moved on the average 2, 8, and 20 microns. And just to compare that to something, how thick is a hair strand? About 50 microns. So they move just about the size of a hair. And if you look in detail how the nerve fibers of the brain looks like, you see that they are built up of something called axons that are shown on the left here. And they are much like the ponytail of the Swedish Minister of Finance. They run in parallel in very nicely oriented structures. And you can also imagine that if you were a water molecule diffusing in there, it would be easier to diffuse along the nerve fiber, because there isn't that many structures that impedes your motion along the nerve fibers. But perpendicular to the nerve fibers, you need to diffuse around all these axons. So water diffusion is much slower in that direction. And by using this diffusion MRI technique, we can make the images darker the longer the water molecules has moved. So if we have a look, for example, in the corpus callosum here, we see that the structure is dark when we make the image dark for water molecules that has moved far in the left-right direction. But we see that the structure is bright when the water molecules, when we encode in the direction through the brain. So by this we can infer in which direction the water molecules are diffusing most prominently. But to assess the structure of the brain, we need also to quantify what's called the anisotropy. And to explain how that works, imagine you had 3 different fiber structures with more and more axons in these structures. Then the diffusion movement perpendicular to this structure would be more and more limited the denser the fiber structure got. But the diffusion movement along the fibers wouldn't change with the density of the fiber structure. So by quantifying the anisotropy, the difference in image contrast when we encode along the fibers and perpendicular to the fibers, we can get a parameter that reflects upon the fiber density of the structure, and that is how we can detect the maturation of white matter. But we can do this also for elderly people. And that has been done for a few years in a project that has been running at the scanners in Malmö, our twin city nearby. And what we see then is something that might be a little saddening for some of the people in the audience. We see that around the age of 65 or 70, the trend is reversed. The maturity goes into reverse and the brain starts to degenerate.
1 minute left.
And while that may be saddening news, there is also some good news, because researchers have used this diffusion MRI technique to study the effect of cognitive training and seen that you can at least reduce the rate of decline. You can keep your brain in shape by doing tough mental exercises, learning a new language, learning to play a new instrument. So to all of you here, please enjoy life and keep your body and brain in shape. Thank you.